Hey guys, it's Mrs. Ulry. What we're going to talk about in this PowerPoint is something called oxidation numbers. Oxidation numbers are somewhat arbitrary. They're a useful tool for helping us to determine whether or not a reaction is oxidation and reduction. We will talk a little bit more about what an oxidation reduction reaction is later, but the focus of this PowerPoint and this video is to talk about what is an oxidation number and how do you assign them. And you've actually done this already when looking at charges in ionic compounds. We're just going to look at it in a slightly different way. So our learning objective for today, by the end of this lesson, so by the end of this video, you should be able to assign oxidation numbers. So oxidation numbers are the number that we assign of an atom if there was a charge on that atom in the compound. So let me say that again. So the oxidation number of an atom is the charge that atom would have if that compound was composed of ions. So ionic compounds are already composed of ions. So we've done that. We've found those charges before. But what we haven't done before is assign charges to atoms within covalent compounds, things made of all nonmetals, because they don't form ions. So this is kind of an arbitrary thing in terms of where do those electrons go when those nonmetals are bonded. So how do you determine an oxidation number? Hey guys, guess what? You just get to memorize a bunch of rules. And again, a lot of this is stuff that we already know. We're just going to apply it in a different way. So, yep, you got to memorize these rules. So, rules for assigning oxidation numbers. Rule number 1, when atoms are by themselves, including diatomics, they have an oxidation number of 0. So, if we look at all of these, so solid sodium, solid iron, solid magnesium metal, they're all going to have oxidation numbers of 0. Diatomic bromine or nitrogen or oxygen or chlorine, in those elemental forms, they're going to have an oxidation number of 0. So if you have an element in its elemental form, its standard form, so metals being solid, bromine standard form is liquid, they're going to have oxidation numbers of 0. Rule number 2, monatomic, meaning single ions, not polyatomic, but monatomic, one atom, have oxidation numbers equaling their charge. So examples, here's the monatomic ion for sodium, which is Na+. Its oxidation number is 1+. Here's the monatomic ion for iron, Fe2+, so its oxidation number is +2. Iron can also have an oxidation number of +3. So if we have iron +3, it'll have an oxidation number of 3. Bromine, when it's not diatomic, so in its ion form, it's Br-, so its oxidation number is -1. Oxygen, 2-, and nitrogen, 3-. Okay. Another rule, rule number 3, the oxidation number of hydrogen is +1 when it's combined with a nonmetal, and it's -1 when it's combined with a metal. So let's take a look. So CH4, carbon is a nonmetal, so hydrogen in this case is going to take on a +1. Lithium is a metal, so in this case hydrogen is going to have an oxidation number of -1. Nitrogen is a nonmetal, so hydrogen here is going to have an oxidation number of +1. Sodium is a metal, so hydrogen is going to have an oxidation number of -1. Rule number 4, the metals in group 1A, so that's the first column on our periodic table, when those metals are in compounds, they're going to have an oxidation number of +1. So examples, lithium hydride, so the lithium has a +1 for its oxidation number. Sodium nitride, sodium again is a group 1 metal, so it's going to have a +1 oxidation number. Potassium oxide, the potassium is group 1, so it's going to have a +1 charge. Rubidium fluoride, again, rubidium group 1, going to have a +1 oxidation number. Rule number 5, the metals in a group 2, when they form a compound, the metal atom is going to have an oxidation number of 2. So examples of that, beryllium chloride, so Be, the oxidation number is going to be positive 2. Magnesium, again, is a group 2 metal, so its oxidation number is plus 2. We have calcium oxide, so the calcium, because it's group 2, is going to have an oxidation number of 2. Barium iodide, so the barium is group 2 metal, so it's going to have a positive 2 oxidation number. Rule number 6, the elements in group 7A, so those are the halogens, so iodine, bromine, chlorine, those guys, they have an oxidation number of -1 when they form a compound. So aluminum fluoride, fluorine is going to have a -1 oxidation number. Calcium chloride, the chlorine is going to have -1 oxidation number. Calcium bromide, bromine is going to have a -1 oxidation number. Magnesium iodide, the iodine is going to have a -1. Rule number 7, oxygen in a compound usually has a charge of -2. The only exception to that rule is when we're looking at the polyatomic ion peroxide. So peroxide has 2 oxygens bound together with a -2 charge. That means each oxygen within that peroxide is going to have an oxidation number of -1. So we just take this charge, -2, divided by the 2 oxygens here. That means each of those oxygen has a -1 oxidation state. So here's some example. So we have K2O. Oxygen is going to be -2 because this is the regular atomic version of oxygen. Here we have K2O2. And I know because potassium's a group 1 metal, that's going to be +1, and there are 2 of them, +2. That tells me that this is my peroxide ion. So that's going to be a -1 charge. I can see that with calcium oxide. So calcium is +2. That means this is a -2 version of oxygen, so -2. But you can also have CaO2, which would be calcium peroxide. And in this case, calcium +2. This whole side is going to be -2 divided by the fact that we have 2 oxygens gives us -1. Okay, rule number 8, the sum of the oxidation numbers in a neutral compound is 0, meaning all the oxidation numbers that we assign within a compound have to add up to 0. So example number 1, here is iron oxide. So if I divide this in half into the positive half and the negative half, I've got Fe, which is going to be my positive side, oxygen, which is going to be my negative side. I know that oxygen almost always has a -2 for its oxidation number. So -2 times the fact that we have 3 oxygens, so 2 times 3 means that this whole side is going to be -6. Because they have to add up to 0, this side has to be +6. -6, +6, that adds up to 0. But there are 2 irons in here, so this total of +6 is divided by 2. So 6 divided by 2, it's going to give me +3 for each of those irons that are there. So the oxidation number for iron is +3, for oxygen it's -2. Example number 2. So here's lithium nitride. So we divide this up, and I know that lithium has a +1 oxidation state because lithium is a group 1 metal, so it always has that +1. There are 3 of them, so 1 times 3 means that this whole positive side is +3. That means the negative side must be -3. +3, -3 add up to 0. Divided by the fact that we have 1 nitrogen means that that nitrogen has an oxidation number of 3. Okay, example number 3, NO, nitrogen monoxide, divide that in half. I know that oxygen is -2. That means the other side has to be +2. There's only 1 of those nitrogens, so that's going to be a +2. So we can also have elements that have more than 1 oxidation state. So here nitrogen was +2. Let's take a look at what nitrogen is when we have nitrogen dioxide. So oxygen is -2. -2 times 2 is 4. If that side is -4, the other side must be +4. There's only one nitrogen, so +4 divided by 1 is +4. So in the last example, nitrogen had an oxidation state of +2, and now it has an oxidation state of +4. Rule number 9, the sum of the oxidation numbers in a polyatomic ion is equal to the charge on that ion. So example number 1, here's phosphate, PO4 3-. So just like we did before, I'm going to divide this in half. I know that oxygen has a -2. There are 4 of them, so -2 times 4 is -8. But this time, the other side's not going to be +8 because our overall charge is -3. So I have to think about, okay, what would I add to -8 to get -3 for my answer? And that would be +5. +5 plus -8 gives me -3. So that means this whole side is +5. There's only one of them, so +5 divided by 1 gives me +5. Okay, example number 2, let's take a look at this. This is permanganate. So if I take a look, oxygen has a -2. -2 times 4 is -8. The charge for this ion is -1, so that means I need a number that's going to add with 8 or -8 to give me -1, so that would be +7. There's only one of these, so 7 divided by 1 is 7. So the oxidation number for manganese would be +7. And then example number 3, we have carbonate. Again, oxygen's -2. -2 times 3 is -6. This has to add up to a charge of -2. So if this side is -6, then this side has to be +4. Because -6 plus +4 would give you -2. There's only one carbon, so 4 divided by 1 gives me an oxidation state of +4 for carbon. Okay, what I'd like you to do is pause the video right here, and I'd like you to try these 7 problems. Go through and see if you can find the oxidation numbers for each one of these numbers, for each one of these compounds. So look for the oxidation number for aluminum and oxygen in the first one, carbon and oxygen in the second, so on and so forth. Pause the video, try these on a piece of scrap paper, and then what I would like you to do is check your answers. When you hit unpause, the next slide will have the answers. So do as I say, pause it, try these on a piece of scrap paper, and then check your answers. Okay, I'm taking your word for it that you did it, so here are the answers. So check your work, make sure that your answers match mine, and make sure that your oxidation numbers look like the oxidation numbers that are here. If you got any of these wrong, please make sure that you either G-chat me, send me an email, use Remind and text me there with whatever questions that you have. All right, good luck. Thanks. Bye, guys.